Training a single AI model can consume more electricity than 100 American homes use in an entire year. Not running it, training it, once. And right now, every major tech company on Earth is training hundreds of them, simultaneously, while promising their shareholders that AI will save the planet. What could possibly go wrong? Let's rewind, not far. Just to 2020, the world had a plan, a clean, green, beautifully PowerPointed plan, net zero by 2050, renewable energy targets, carbon credits, ESG funds, the whole 9 yards. Data centers, those massive humming warehouses full of servers, accounted for about 1% of global electricity consumption. Annoying, manageable. The kind of number that lets you sleep at night. Then someone decided to make computers that could think, not just calculate, not just search. Think, write, draw, diagnose diseases, write legal briefs, pretend to be your therapist at 2 a.m., and to do all of that, they needed power, a lot of it. The International Energy Agency, not exactly a doomer organization, released a report in 2024 that quietly set the internet on fire. Data centers, they projected, could double their electricity consumption by 2026. From roughly 200 terawatt-hours per year to over 400 terawatt-hours. For context, 400 terawatt-hours is approximately the entire annual electricity consumption of France. France, gone. Just absorbed into the hum of servers answering questions like, write me a poem about my cat wearing a cowboy hat. Here's where it gets uncomfortable. A simple Google search uses about 0.3 watt-hours of energy. Negligible. You've done 10,000 of them and you're basically neutral. A single ChatGPT query? Roughly 10 watt-hours. Around 30 times more expensive, energetically speaking. Fine, you say. That's still small. Manageable. Now do that math at scale. ChatGPT alone hit 100 million users in its first 2 months. The fastest consumer product adoption in human history. By 2024, there were over 1.8 billion AI interactions happening every single day across all major platforms. Not interesting anymore. Not manageable. And that's just inference, the part where you use the AI. Training is where the real horror show begins. Training GPT-3 consumed an estimated 1,287 megawatt-hours of electricity, emitting roughly 552 tons of CO2. That's the equivalent of flying from New York to London about 550 times. GPT-4? OpenAI won't say. They've gone remarkably quiet on the energy numbers since GPT-3. Researchers estimate it was orders of magnitude higher. Not a denial, not a number, just vibes and a sustainability pledge. Here's the twist nobody saw coming. The companies that need the most energy to build AI are the same companies that made the loudest net zero promises. Microsoft pledged to be carbon negative by 2030. Noble, admirable. Also, Microsoft is OpenAI's biggest backer and has integrated AI into literally every product it sells. Their 2024 environmental report quietly revealed that their carbon emissions had increased 29% since 2020. Not decreased, increased. By 29%, their response? They're working on it. They've invested in carbon capture. They're buying more renewable energy certificates, carbon credits, the confession booth of corporate climate sin. Google? Same story. Carbon emissions up 48% since 2019. The year they made their big carbon neutral announcement. Not a small rounding error, not a temporary blip. 48%, gone in the opposite direction. The water problem, because of course, there's a water problem. Here's the part they really don't talk about. AI doesn't just eat electricity, it drinks water. Data centers use enormous quantities of water for cooling. Those servers run hot, obviously, and you need something to keep them from melting into expensive puddles. Microsoft's data centers consumed approximately 6.4 million cubic meters of water in 2022, up 34% from the year before. Training GPT-4 alone required roughly 700,000 liters of clean water, enough to produce 370 BMW cars. Now, here's the kicker. A lot of these data centers are being built in places that already have water problems. Arizona, Texas, Nevada, the American Southwest, a region experiencing its worst megadrought in 200 years. Phoenix, Arizona, home to some of the largest AI data center clusters in the world, also currently watching its water table drop like a bad stock after an earnings miss. Mesa, Arizona passed a resolution asking Microsoft to halt expansion of a planned data center campus until water impact studies were completed. Microsoft's response was to proceed anyway. What could possibly go wrong? It's not just about carbon. or water. It's about whether the lights stay on. The United States power grid was not designed for this. The American Society of Civil Engineers gives U.S. energy infrastructure a C grade. The grid is old, creaky, and already struggling with demand surges from electric vehicles and heat waves that are getting worse every year. Now add AI. Northern Virginia, known as Data Center Alley, hosts roughly 70% of the world's internet traffic and has become the most concentrated hub of AI computing on the planet. Dominion Energy, the regional utility, warned in 2023 that new data center demand was straining the grid so severely that they might not be able to connect new facilities for years. The irony? These are the same data centers helping to build the AI systems that companies are marketing as tools to optimize the power grid. We are using a fire hose to fight a fire hose fire. Georgia Power, PG&E, Duke Energy. Utilities across the country are quietly revising their decade-long demand forecasts upward by enormous margins, not because of population growth or factory expansion, but specifically because of AI. Georgia Power revised its 10-year demand forecast up by 17 gigawatts in a single update. That's the equivalent of adding the electricity needs of about 13 million homes because of AI in one update. And so, inevitably, desperately, the tech giants turned to nuclear, not metaphorically. Microsoft signed a deal to restart Unit 1 of 3 Mile Island. That 3 Mile Island, the one that had a partial meltdown in 1979, the one that was shut down in 2019, the one that became a symbol of everything nuclear energy's opponents warned about. They're reopening it. To power AI, the plant will be rechristened the Crane Clean Energy Center because nothing says fresh start like a rebrand. It's expected to provide 835 megawatts of power, almost entirely earmarked for Microsoft's data centers. Google invested in a startup called Kairos Power that's building small modular reactors specifically for data center use. Amazon bought a nuclear-powered data center campus outright, the Susquehanna Nuclear Plant in Pennsylvania, to power AWS, Meta, Oracle. They're all circling nuclear like it's the last lifeboat on the Titanic, which, depending on your view of AI's energy trajectory, it might be. Let that land for a second. The companies building the technology we're told will solve climate change are quietly reviving and repurposing nuclear infrastructure. Infrastructure the world spent decades trying to phase out, because renewables alone cannot come close to meeting the demand. Solar panels, great. Wind turbines, beautiful. Can they power 100,000 GPUs running around the clock for months while training a frontier model? Not even close. Not a gap. Not a slight shortfall. A completely different order of magnitude. This isn't abstract. It never is. In 2023, residents near a data center cluster in rural Iowa complained of constant low-frequency noise, a hum that never stopped day or night, shaking windows and making sleep impossible. The data centers had received millions in local tax incentives. The community got the noise. In Chile, Microsoft's planned data center drew protests from communities already dealing with water scarcity in the Andes foothills. Locals, we don't have enough water. Microsoft, we have sustainability commitments. In the UK, planning applications for AI data centers are so numerous that they're clogging local councils, communities that never ask to be the world's computing infrastructure and are discovering they have very little say in the matter. And meanwhile, electricity prices. When massive new loads come online, and AI data centers are massive new loads, somebody pays for the grid upgrades, somebody pays for the new transmission lines. Somebody pays for the reserve capacity. That somebody, historically, is the residential customer. You, on your monthly bill. Studies in Texas found that large data center clusters were correlated with measurable increases in retail electricity prices for nearby households. The AI revolution is being subsidized, in part by people who can't afford it. Look, AI will almost certainly deliver genuine value. Medicine, science, logistics, education. The optimists aren't entirely wrong. But here's the question that nobody in a keynote wants to answer. Who decided that the right way to build the future was to use the resources of the present at a pace that assumes the future will figure it out? The energy crisis in AI isn't a bug. It's not an oversight. It's a direct consequence of a culture that treats scale as the only metric that matters. Scale of users, scale of parameters, scale of valuation, without asking what the scaling costs and who pays it. We are building thinking machines by feeding them the metabolism of cities. We are cooling them with water from drought-stricken aquifers. We are powering them by reopening reactors we once feared beside rivers we once wanted to protect. And every quarter, someone in a glass tower shows a slide with a hockey stick curve going up and to the right, and the room applauds. They call it progress. The meter is still running. The most dangerous assumption in technology is that the problems created by progress will be solved by more progress before the bill comes due.